Hello, I'm back. Doo-doo-doo. So, hi Penguin, hi Totally Shoes, hi there Teufel, hello Hulakdar. Hello good sir, I recently found out that Zig exists and started tinkering with it. Cool. I found it is painfully slow to compile on my machine though. Is it a Windows issue or overall Zig issue? Um, oh, you mentioned Windows. So, um, Zig has a compilation model where it um how can I say um we have a work in progress implementation of incremental compilation, which will make compilation faster on all machines once it's ready. But what happens normally is that Zig compiles. There is a caching, but when it comes to compiling Zig code, it will always look at all uh, source files and reparse them from scratch every single time. Now, here's the thing. Accessing a lot of files on Linux and macOS as well, like on non-Windows systems, is not a problem because accessing files is fast. On Windows, accessing a lot of files is very, very slow if you have Windows Defender enabled. So, um, if you were to turn off Windows Defender entirely, I think that you would probably experience a big speed up. In theory, you wouldn't have to do this because you could exclude specific paths from Windows Defender. The problem is that those paths have to be where you have installed Zig, which is where the standard library source files are. Then it would have to be the directories where caches are and the directories where your source code is. Long story short, you can definitely exclude specific directories, but it is likely that you're not going to do that correctly. And so it's very likely that if you try to exclude specific directories, you will not see any speed up because you will have not correctly excluded all the necessary directories. So here's my suggestion. Try turning off Windows Defender. See if you perceive any change in compilation speed after turning off Windows Defender, and then consider if you want to keep it off. Uh, ultimately, it's your choice. Windows Defender is not all that useful, to be fair. I mean, Windows is a pile of bugs, so you know what? I don't even know. Um, I guess it depends on what you do on your machine. But that is one way of fixing it. In the future, there will be Zig will probably just generally do fewer file accesses, and so it will be better. But to be clear, this is not a flaw in Zig. This is Windows being a absolutely ridiculous operating system. Windows Defender is garbage. Okay, so what happened since I left off yesterday? I spoke with Mlog. We figured out what was the error that I was getting at the end. I think I also implemented. I don't remember if I did run. If I ran the RAD executable right away. Did I? Was I it on stream? Where was I on stream when I um started composing the remote URL? I don't remember that part. Maybe no. In any case, so long story short, um, run invite follow is mostly implemented. It has, I believe, one flow that remains. I've also implemented a deletion. Um, I think the only flow that remains is that it doesn't recognize duplicates. This should complain when it finds duplicates. Then mm, 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 mm. So what I'm gonna do here is what do I want to implement next? I guess I want to implement sync before we look into anything else. You didn't have the no sync part? Yes, this is the workaround. Essentially, before pushing the ref, first we delete it. That bypasses the bug, but the bug is still there, and it's a patch in Radical's tooling that MLog made um, in their remote helper. So this is a workaround that should be deleted once if they merge this. Or in any case, assuming that they acknowledge that this is an issue and it should be fixed either through that patch or some other way. Then, I think that before we before we manipulate the list, we should also check that it is coherent. So the coherence check, um, how should we do the coherence check? I think there should be a function that does the coherence check. A coherence check in this case would be complain if there are duplicate values. Ideally, we would also want to recognize these values as invalid IDs, but we don't know how to do this yet. Actually, if anybody is interested and willing to help, if you go see if you can find somewhere in the Radical stuff exactly what is the format that we're looking at. I think they are. I guess they are SHA-255, 256 hashes. So that means that we could parse them as such, maybe, and check if that checks out. I guess. Frankly, I I think they also probably would benefit from a redundancy digit. The format of what the ID is? Yes. More specifically, a DID is this. A DID is DID colon key colon Z6 blah 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 blah. This is the DID. This part here, which is the one that I'm wondering about, is the NID, is the node ID. Right now they are essentially the same thing, except that syntactically the DID also has the DID colon key colon prefix. I think occasionally in some contexts you can also probably see people say DID when they mean the identifier that corresponds to a user, and NID when they want to put focus on the fact that they are talking about the identifier of a node. And right now these two concepts are kind of intertwined because there's no distinction, although there is, for example, my DID will author repositories, but there are some nodes out there who don't author anything. It's an ED25519 public key. Right. And what is that? Is that then a base 16 hash? The question is, what should I use to validate that a given string is a valid node ID, or maybe not valid because valid is valid, yes, maybe not existing but valid. In the meantime, yeah, so we need I think a function for checking coherency, except that here, when deleting, we just want to check that what is already there is coherent first, and that's fine. But when we're adding, we want to check that the thing is coherent, but at the same time, we also want to say, well, it is coherent, but also assume that we're going to add this. So we want to complain if uh, if the idea already exists. So I guess we could have a function that accepts an optional to add. So here's what I'm starting to think. We're finally going to create the main directory. And then Zig.list.zig, I guess. And in list.zig, we're going to have validate. To add that's void. Is it not working overtime? No, it's not really. The camera maybe makes it look like I'm turning my head more than what I am actually I'm doing. I have two monitors and a camera in the middle. So when I develop, I will look at the left monitor. Then I also have the right monitor where I read. Well, I can read chat on both sides, but this is where I look at OBS and maybe other things. From bytes, non-canonical. Okay. 32. So length has to be 32. Okay. If a function accepts an array, maybe it should be marked in line. I'm not sure. Curve.reject non-canonical. Oh, that's more like what we want then. Reject non-canonical. FE, reject non-canonical. What's FE? Okay, but this seems kind of what we want. So thank you. So maybe we could have, instead of list.zig, we could have validate.zig. And then in here we put validation stuff. Because I think that we're not going to need that many list manipulation. Oh no, we are definitely going to need list manipulation things. Let's keep it list. Okay, to add consuate, then how does it work? Const no, var it sed mem. You know what? The problem with this is that no, this is the wrong approach, because this is scanning, is going to scan through the data once, and then guess what? We're gonna scan again. So that sucks because when deleting, we're gonna do our own scan. When appending, we're not gonna do it, but I think we need something different, which is essentially just a hash map. Uh, yeah. We need just a hash map. And you know what? Maybe shit, I pressed back one too many times and the browser punished me for it. Maybe we can do this. What's in a public key? An array of bytes. Okay, so it's right. Yeah. No, so that's what we want for sure. And then we can make the hash map of, we can make an auto hash map of array of 32 bytes. Arrays of 32 bytes. And that's it. So I think we can do it like this. Var scene and IDs is a SCD auto hash map unmanaged of 32 U8s void starts empty. For every line, mm-hmm. This does not sound like Windows Defender. Semantic analysis 10 seconds. Hmm. Um. What are you building? Oh, also, you know how you could check this in a different way? Um, try to do the same thing inside of WSL. So get into WSL, do everything in WSL. So don't use WSL, but then do not go into a host directory. Stay inside the the WSL file system, and run Zig there. See if there's any difference. If it takes the same amount of time, or roughly that, then yeah, it's not Windows Defender, or it's not Windows per se. It takes what it takes. Okay, Ghosty VT debug. What is Ghosty VT? I mean, I know what's Ghosty. I don't know what's VT. Um, is it like libghosty essentially? Well, in any case, um, roughly speaking, guesstimating, again, I don't know what VT is specifically in the Ghost ecosystem, but guesstimating how big Ghosty is, 10 seconds of semantic analysis, that is kind of on par with what I would expect. So chances are. So I would still do the WSL test um, just for completeness sake. But this does not sound insane. Like, so what you're saying is that this was a compilation that took what is it, 15 seconds 15 seconds for a build, an uncached build. Well, not fully uncached. I'm assuming you already had like the first time build done. So yeah, this is this is it. This is kind of how it is. Keep in mind, uh, this is gonna be better when it comes to rebuilds, but for a single build that is probably kind of it with status quo. Again, this is a guesstimate. This was one of the items, 1.5 minutes. Okay, if you do the build again, how long does it take? And then how long does it take if you delete the local Zig cache? So the Zig cache directory in the project itself. Because so when you build clean from Zig, the first time it will have to build the CLib, the C++, the libc, the libc++, so the C++ standard library, if you never built them. It also, depending on which version of Zig you're using, newer versions of Zig will also have to build the build system for the first time. So that could have a significant impact in what you're doing there. Also, another thing, you know what you could do also? Do this, because I think the more than time report, here's what's more interesting. Do Zig build, and then do -- summary all. Well, okay, it's not gonna work on my project here because I have compile errors because I'm touching stuff. But if you do summary all, it will show you the entire build graph and it will tell you how long each step took. And so again, I don't know what Ghosty is doing. If Ghosty is like compiling, like you're making a debug build of Ghosty, libghosty, fine. But if libghosty, as part of its build process, makes like release builds of tooling that then it executes as part of its build pipeline, then yeah, that's, for example, going to be another time sink. And it's ultimately, something to do with the project itself. So maybe some complexity that it might not be immediately obvious. That's what I'm trying to say. Can you give a 20-second explanation of what this invite tree project is supposed to do? I play with Radical and I host a couple of toy projects on it. The Radical invite tree is supposed to be essentially a. I'm assuming that you're familiar with the basics of Radical, so you know what a delegate is. The idea is, what Radical gives you out of the box is that you can, for a given repository, is that you can either seed everything that is in the network, so scope equals all, or you can seed only stuff authored by people that you follow. That would be scope equals followed, or follows, or follow. I don't remember, but in any case, it's the other option that you can set to scope. Here we are essentially implementing a third option, where the idea is that each repository is able to specify its own list of list of nodes that you should pull from, or not necessarily pull from directly, but like the list, of, I guess, authors. So that would be DIDs, identities, and IDs. Namespaces, Git namespaces that you should be pulling from. But that list is essentially the result of a tree that starts from the delegates. So the idea is everybody creates their own list and they put it in the repo. So they think of imagine that they create a branch where they put that list, and everybody has their own version of that branch. Concretely, this is not implemented through branches, but that's like an implementation detail. So everybody puts in the repo their own list of people that they want to invite. But then this tool, when you run the sync command, which I have yet to implement, will start from the delegates. It will find their lists for every entry in their list. So their list will contain a bunch of DIDs. For each one of these people then is now considered part of the invite tree. So they get followed. And then for each one of them, we pool their namespace so that we can find their own list. And in turn, and we do that recursively, right? So we expand the entire tree. That means that you could be a random dude who you make your own invite list, but if you yourself are not being invited by somebody who is already in, then your list is gonna do nothing. So this is how the invite tree works. It's essentially kind of like a cob, if you're familiar with radical cobs, so collaborative objects, so like issues and patches, except that the implementation is slightly different because it doesn't need all the machinery that cobs come with, because this doesn't need to be ACRDT. This is absolutely the right idea. Solves dependency availability problems. I mean, radical in general, yes. This specific thing is essentially meant to have to distribute the work of filtering whose issues you would want to see. If you have a tiny project, then you can do scope equals all and it's fine, because you're not being overwhelmed by issues, and so you want to make sure that you have the lowest amount of friction possible. You want to see everybody's issue if they open one, ideally. Modulo may be spam. You would want to avoid spam, which right now is not a big problem, at least as I have experienced it in Radical. But then if your project grows and you get to a point where you have a project that has a lot of contributors and a lot of people that want to do contributions, but who are, it's not necessarily being evil, and it's neither a matter of like elitism where, only the selected few have the right to contribute, but it's more like, in practical terms, there's a bunch of people that have an LLM, and the LLM hallucinates horribly some solution to a bug or something like that, or hallucinates a bug in the first place. And then they open this super detailed issue, right, where they dissect the problem, except it's entirely hallucinated or mostly hallucinated, and then they have no idea what they're doing. So in that case, I think it's reasonable to want to exclude these people from being able to contribute. So how do you do that? Well, if you can do a fully manual system where you block that person, but then if you have a set of core contributors, when one person blocks somebody, then all the other ones will have to run the block command again manually. And then what about all the other contributors? So essentially, the invite tree is a way of distributing this stuff and allowing people that you have let in to also allow other people in, so that you can distribute this moderation effort, this triage effort, if you will. That's the idea. So it's not a thing that is necessary for all projects. I will not use this invite tree implementation in my own personal projects, most likely, unless one of them ever reaches a big enough scale. But for projects that are at the scale of Zig, this is kind of necessary tooling, or let's say highly desirable. Attention of maintenance is a limited resource. I agree that we need a solution for this. Yeah, that's kind of the idea. And invite trees, what's interesting is that you don't have invite trees in Git. You don't have invite trees in Codeberg. I think Mitchell made an invite tree implementation that works on Git, but that's entirely orchestrated via bots. So yeah, it kind of works, but then you have bots, spamming comments, and it's a bolted on system. Here, I mean, this is also user land. So this is also, in a sense, if you will, bolted on. But I think that Radical gives you a chance of implementing this in a much more reasonable manner. And also, I think that if we prove that this is a solid concept, I think there is a chance that there might be an interest in wanting to upstream this in Radical proper. Obviously, I cannot, I'm not part of the Radical team. I cannot speak for them. Obviously, I've never even tried this yet. So who knows where this will go. But I do think that this is a uh, meaningful tooling to have for projects that are at the stage where the Zig project is. And I think that it's not just the Zig project at this stage. There are also other projects that would benefit from this. So we'll see. In any case, I need to finish implementing it. So that's the idea. So, okay, so here I was about to complain that the list contains a duplicate and that we want to delete it. One thing that we could do instead of deleting it is just remove it. If it is a duplicate value, why not do that? But you know what? No, let's have the user fuck this up. The user unfucks it. We give them tooling to guarantee that this is never necessary. So if they used like if they edited this thing manually and they messed it up, they do that again to unmess it. So invite list contains duplicate values for an ID, blah blah blah. Use rad invite follow to edit the list in your editor, in an editor, and fix this. Also, I think I can do this. It's more readable. Nice. And here we do cmd.nid. Then, so here we are in the cases I was saying where we want to delete things. So we keep doing this for what is before. When we do find the entry, which is essentially here we have found the entry. So we do scene nids dot put no clobber. Put no clobber. And then the next thing that we do is we look at the next line. And then I think we need to do a while loop. So we look at the next line. Damn, because here we look at the next line and we want to do this, but we also want to do everything in a loop, and we want also to include this here as the thing that we worry about. So how do we do this? Um, we could put this in a while loop, and then we have an if that is true only on the first iteration. That will work. Hello, Quint. Alternatively, we could copy the iterator. Yeah. So check this out. So we advance list IT copy. Is the refs invite stuff working? Hey, Quint. Yes, it is. Or rather, it's not fully implemented yet. I'm still working on it, but I got unblocked. Yeah, from where I was yesterday. I'm now adding consistency checks for the list, and then I'm going to implement sync. So we'll see how far I get with sync today. But after I've implemented sync, this could actually be taken for a test drive. Yeah. With the caveat that right now we will take over your follow list. So something to keep in mind, which is suboptimal, but it is essentially, I would say, a temporary thing to make progress. I had a call this morning with the radical people, and they seemed open to the idea of introducing scope equals list. So essentially, like having a per repository list of follows, which then you could drive through this system, or you could drive through some other policy. So you decide how you want to do it. Um, so we were saying list IT copy, blah, blah, blah. And then we do while list IT.next. Line. Oh, right. This is because we're still inside of this while loop. But frankly, you have no reason to still be in this while loop. Because after this, we could be done. There's no reason to still be inside, right? Oh, this is using line though. So we could put this in here. Maybe we don't even need this namespace then. Well, the scope. We look at the line, and then we do this again. Frankly, we could have made this a function that we call oh well. So yeah, this works. Am I missing anything? I'm missing validation. So let's validate the NID. So how do we validate NID? I guess we want to do it up here. Oh, this is interesting actually. This would be part of parsing the command. Like we need to check that the NID is correct. So SED crypto 255. Wait, how the heck do you do this? Oh, it's excuse me? There has to be an escaped thing, right? Oh, it doesn't show up. Is it this? Whoops. Hey, is it 25599? I forgot. 19. That's not a thing. What I feel like I'm getting lied to by the documentation. Is in sign. So what the heck is this? Verify batch. Curve key pair public key. Final verifier noise length. Oh shit. Curve. Reject non-canonical. Reject identity. Um, Public key. What did you say? Public key. No, but I don't want to make a public key. I want to just to reject non-canonical, right? We don't care about the other thing. So reject non-canonical C NID dot star. And then I think we also need a pointer cast, don't we? Oh shit, but I don't think we're gonna be able to do this. Wait, we can do this. Let's go. And then we can do catch. And this is gonna be fatal.message. Have you already decoded the NID here? What do you mean decoded? It's 32 bytes, right? So I'm keeping those 32 bytes. They are base 58 encoded. Oh, wait. So, okay. So you don't pass the text representation. So these are, so what you're saying is that, wait a second. Rad self. Let me just run one quick check. Like, how long is this? That's 48 characters. Oh, yeah, good point. So yes, I need to decode them first. That makes sense. Z6MK is the base 58 representation. Gotcha. I don't think SED has base 58. God damn it. God damn it. And you know what? Now I remember. I think these bad boys don't always have the same exact length. Steal it. Let's go. Thank you. Thank you. Okay, so that means that we need to decode it first. Um, um, I don't know. What should the variable name be? Need bytes. I don't know. Need bytes is gonna be and 80 bytes is gonna be oh wait, you need an allocator? Oh, it's because this is for arbitrarily long stuff. Right, this is not based on the assumption that it's just 32 original bytes. That's okay. Well, here's what we could do. Let's see if this works. You have one that doesn't require that? Holy shit. Content int. Do you mind if I copy it? Thank you. Oh no. Well, I mean, for now I'm not doing match. Holy shit. Brutal. This pace was brutal. Holy cow. Actually, wait. You know what? Um, whatever. Sublime text is fine. Okay, there we go. Um, do you? I do need to strip the Z prefix. Oh, I need to strip Z6MK. Okay, I see. Well, interesting also that it has to start with Z6MK. So that's another check that we could make. That's good. So you need to decode first, then strip away the prefix. Parse NID. NID prefix len plus len. So this is 32, I'm guessing, and this is the length of Z6MK. Yeah. And where is the other quantity defined? There we go. Oh, wait. Is this because they were being clever? That's ED01. I see. Cool. Well, I hope you don't mind. I'm gonna steal this stuff as well then. Kinda. So I guess we could put this in base. We could put it in here. We could make a file for an ID. We could have one file do both things. Sorry, this one, I mean. Um, uh, 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 uh. Okay, let me think how we want this to work. I think I want to rename these to key essentially, and then have these be non-public functions. Because I think we're not gonna worry about them. I don't think we're gonna worry about them. We're not gonna need them being useful elsewhere. And I think up here, then we can do this. NID prefix, yes. NID len is 32. Oh, the code multibase? Where's my decode multibase? Caller owns the result. Oh, wait a second. I didn't properly paste. That's what's happening. Why did I fail at pasting? Somehow I failed at pasting. Uh-oh. Interesting. Okay, there is something going on with my clipboard that I'm not sure about. Copy again. This time should work. This time it does work. Okay, thank you. Uh, yeah, that is actually perfect. And you know what? Kinda because we don't even need the results, so we can do we can do invalid key type void, or we could make it a boolean. We can make it a boolean like reject, validate, reject, reject invalid key. Although the error does help, so maybe, yeah, that's fine. I guess this is fine. Okay, reject invalid key. Actually, no, from here, move. No, you're joking. Oh. Oh, shit. Okay. Follow. Also, we can call it reject invalid because it's already namespace under key. There we go. So we complain here about the invalid ID argument, and um, in here, as we look at lines, before testing the line, we do a reject invalid line, and then we do catch invite list contains in an invalid NID at contains invalid NID value, whatever it is, at line whatever that is. Here's the problem. To be able to say the line, I guess we can just count new lines. It's fine. Okay, so here's how we do it. NID value line, and then we do std mem dot count scalar u8. This is gonna be uh list from 0 until, let me think about it. I guess it can be until list it dot index minus 1, and the element is going to be a new line. So let me explain this. Why am I counting scalars? Because I'm using tokenize. Tokenize skips subsequent new lines. So like empty lines will be skipped. It's not going to return me an empty token because tokenize doesn't return empty token. There's no empty token. Um, so to provide a proper line count, um, we need to count multiple new lines. It's an abomination. It is, but I'm trying to make this resilient to Windows users with misconfigured Git setups. Um, yeah, so these in theory should give us a good result. It's going to be 0 indexed, so maybe we want to do +1. what the fuck am I saying here? Okay. Then that's awesome. Then we do this again down here. Then here when we're adding stuff, we need to scroll the whole list. So here we need to do the same. We need more logic. So we need essentially this. Okay, let's double check what we're doing here. We tokenize the list. By the way, this is showing us that we're tokenizing the list in both cases, so we might as well pull that out. Then, yeah, rejecting valid line. We also here need to look for duplicates, just like we were doing above. So we need to do this. Here. This is unreachable code. Oh, shit. Right. Okay, never mind. I think I broke something up here. I'll need to fix it again. One sec. So far so good. We're missing finding a collision with the ID that you wanted to add, which I think we need to do separately. So here we do if std mem.equal u8 line cmd.nid. We essentially want something like this. A simplified version of this. Invite. NID already present in list. In your invite list. There you go. Okay. So we check for duplicates. We check for invalid values. Yeah, this is all well and good. Okay, what the fuck did I break up here? Yeah, the problem is here because we do put no clubber. Then we do the second half. Yeah, the problem is what if we... So, okay, here's how it is. Else. And this contains this. This is what I failed to preserve. If the search goes through and we never find the NID that we are deleting. By the way, here I'm implementing the case where you're adding and the case where you're passing -d and you are deleting. So this is what these what is it, the other one, these two branches are doing here. So in this case, we do the search. Search leads us nowhere. Error out with NID is not present in your invite list. Okay, this all seems good. Do we build? What the fuck did I do with my Zig? Okay, no, this is fine. Did I mess up? My fixed buffer allocator? Oh yeah, I think I totally did. Oh shit, I pasted in here. What a fucking moron. Oh my god. Okay, we can fix it like this. Zig Zig up master. Give me a new Zig. I'm skipping my problems this way. That explains what happened with a copy paste. Yeah, that's I think a better place for that line. And it will follow the Zig. Right. So main the Zig now has to do this. Then what's the next one? Fatal in sync. Okay, let's see. Expected type U32, blah blah blah. Unconsuate. Oh, yeah, about that. So, ah, I guess now the question is, would there be any okay, I actually hijacked the original function in order to make it a reject function instead of generating an extracted um a decoded NID. But would there be any benefit in doing that way? Yeah, I think there would totally be. So never mind. I think I'm gonna walk this decision back. Yeah. But then I think I need to do dot star. So in follow. So rejecting valid becomes const. What do we call it? Oh, that means that we also need to decode our NID. Let me think about it for a second. Why undefined plus mem set instead of splat? Maybe this code is just not splat aware. Oh, here. Yeah. I think this can also be the same, right? Never mind. Dot star. Maybe. Does that work? That might not work. Also, I messed up. You know what? I'm changing too many things at a time. Let me first do this. Okay. So do we decode also the NID? Do we call it NID STR? Can you do equality between arrays? Okay, let's see how this goes. Oh. Oh, shit. Wait. So what do you think about this? Operator equals is not allowed. Okay. There's a mem copy, there's no mem compare, so yeah, it's this. Although I don't know if this is I think we could do better than this, right? Oh well. Um no, they refused it because they were sometime known to be the same size. It told me that it was just not allowed with the array type, which is fair. Comparison of 32U8 with null 214. Hey Dylan, thank you for the raid. Hello. Hello. Welcome raiders. Raided. Oh yeah. Welcome everybody. So here's what I'm working on in case you're interested. Check out radical.dev. So if you've never heard of it, Radical is a decentralized Git forge. You know, GitHub is falling apart. Codeberg is one solution, but it's a non-profit, which is nice. It means that it's not going to shitify the same way that Git did. And also is in the process of doing. Like GitHub is not done in shitifying, that is for sure. But Codeberg has also its own issues. So I'm exploring a Radical, which is distributed. It's peer-to-peer. People like, whenever people hear peer-to-peer, they think, oh, so it's like BitTorrent. And the answer is that, yeah, kinda, very vaguely. Not everything that is peer-to-peer is like BitTorrent. I know there's a bunch of Zoomers out here who have only ever used BitTorrent, but before BitTorrent, there were also other peer-to-peer networks. I don't know, maybe there's some boomers in here who remember Nutella, like Emule, Shariaza, DC++, Napster. What else was out there? Was Audio Galaxy peer-to-peer? It must have been. In any case, peer-to-peer doesn't necessarily mean BitTorrent. Git fork. Forjo is a Git fork. So Codeberg is a Git fork. Radical is not. Radical is a completely different system built on top of Git. So it's all, generally speaking, from scratch. So the nice thing about Radical is that repositories are replicated across the network. And there's like a cryptographic way of being able to fetch a copy of a repository from other locations maintained by, managed by other people. But because of the cryptographic signing, you know that what you're getting is the original copy and it has not been tampered with. So, which is an important quality if you want to be able to download something from other places rather than the original location, which is what happens like with GitHub and Company. I mean, in the case of GitHub and Company, you have to trust them, right? You have to trust that GitHub didn't mess with the source code, but generally speaking, it's fine to do in practical terms. With Radical, you don't even have to trust anybody other than the original author, which is cool. So what am I doing? I'm implementing an invite tree system for it. The way it works is that we are creating a series of invite lists that every contributor to the repository can maintain in a branch. They have their own branch, quote unquote. It's not really a branch. It's a Git blob tied to a special ref. If you're not familiar with Git internals, you can think of it as a branch. That's good enough. And you have your invite list. And so you add people in your invite list. And so this tool that I'm working on will essentially then start from the maintainers, people that have write access essentially to the official main branch. We start from them. We collect their invite lists, and then for every person mentioned in their invite list, we go and collect their invite lists, and so on and so forth. That creates the tree. So now I'm implementing the command to add a new entry to that list. And I'm implementing, consistency checks. Like you try to add something, but there are duplicates, or you passed a garbage value. So we should be able to detect that. Let's see. Expected type const u8 found optional const u8 216. Okay, we're getting closer. Note, error invalid empty, invalid base, invalid chart and length, not a member of the destination set. Right. What was the original source code doing? Did you have an error set for this? Or you left it undefined? By the way, a couple recommendations in case you're interested. If you're making a top level thing, my recommendation is that this is a legitimate use case to create a binding for add this. What I usually do, again, just a recommendation, feel free to follow it or not. But what I usually do is that up top, even above const std, I do const, what would be like const key equals at this, and then I use key elsewhere. The distributed implementation remembers who added who? Yes, because you know that who added who by looking at specific people's invite lists. So you can see paths. The same person could be invited by multiple people. So we call it an invite tree because ultimately we derive a tree and we don't care too much about duplicate links. But this is really an invite graph in terms of like the underlying data structure. I don't use line numbers. I had them on before, but I don't care. I see the line number down here where I'm at. I usually use go to commands. In Helix, I would do colon and then the line number, except that in Flow, this doesn't work yet. So Neuroside hopefully will implement this eventually. So I don't know. It's not super important for me to have line numbers on the side. I get it that people use maybe relative line numbers for jumps. I don't do that. So I like if I have to jump around, I would prefer to do that with search. Otherwise, I'm just happy with using arrows. I don't know. Okay, so what do we do with this error set? Either we collapse it. There are two options. Either we collapse it or into just invalid key, or I don't like leaving it unspecified. So either I make a proper error set for it. I think it's fine to collapse it for now. So we built. Here's my test repository. No, not this one. This one. So now if I do this, it should complain invalid NID argument. That's fair. That's true. Rad self DID. This is interesting because yeah, we don't accept this. Maybe we should also add some flexibility to accept a full DID. So essentially check if the argument starts with the ID key and then we delete that. Or alternatively, maybe we should preserve the DID key prefix in the case that there are multiple DIDs in the future. I think in terms of future proofing, that would not be a bad idea, but we don't know yet how the potential new future DIDs will interact with namespaces. So we're going to leave it at that for now. I would just feel lost without line numbers just as a comfort. My experience has been that when I started working with Zig, I used to have a bigger need for spatial, I don't know what to call it, like signage. I used to like having, the file tree on the side. Like when I used to use Sublime, oh shit, it's not here in this case because I guess this is a single file. But when you have the file navigation on the side, I used to like it, and then I abandoned it completely because I got used to just searching for files, and then I don't have tabs. Like usually you can configure like Flow out of the box will have a top bar with open tabs, and I always disable it because I'm happy to. Just use space F to search file and space B to see what are my open files. And I essentially search. So essentially I have given up most spatial things and I think of things in terms of search. If you have gone through this transformation when it comes to multiple files, but within a single file, you don't feel comfortable doing this yet, maybe this is something that you could consider experimenting with. It might be that it's just not for you. It's not the end of. It's not a big deal either way. But it might be that it turns out that you end up liking it, maybe even more than your current approach to it. I've given up completely trying to have a fully spatial reasoning when it comes to this stuff, and I just jump around using search. I don't know. I find it comfy. I guess it depends from person to person. In any case, so here's my thing. So we can do rad invite follow this DID. Ooh, and rad sync failed because this repository does not have seeds. This is actually fair. I'm gonna comment out the initial rad sync for now. This is necessary. Oh man, maybe we should pass a. There should be like run fallible where on failure it doesn't complain. Damn. Although it should complain in this case. It's just a matter of me testing right now. Self DID, porcelain. So I had an empty list and I ended up adding an entry to it. And if we do git show refs invite follow, now there's one entry in it. If I do it again, it will complain NID already present in your invite list. I'm gonna, I don't know, change it. Try it again. I'm gonna remove it. Yeah, and we see here that this contains two things. Invite list contains duplicate value for an ID. That's not true, man. What are you talking about? I think I moved something too early. Oh no, you know what? It's in the deletion case. I'm adding something that I shouldn't add, I think. Let me think. Yeah, because we add everything in this case. Wait, how does this work? Let's see. Makes sense. I think I would just feel lost without line numbers, just comfort, a habit. Same with my Vim setup, except I do use relative line numbers to jump. Okay. I might give it a try, but Vim doesn't have a great vertical movement jump word to word capability. I see. There's a thing that I don't use much, which some people like. Actually, I don't use it at all, but I think it's um so this is Helix that I have open right now, and it's space um I don't think it's J. Sorry, I need to find it in the list again because I don't remember what's it called. Replace, paste, window, open, perform, workspace diagnostics, simple jump. Is it jump list? Is it J? No. Is it not in here? Mm, maybe it's not here. Is it in space space D? No, space square bracket D. Maybe it is in D. Line number, column, last line files, start and next up down modification. Oh, there we go. Jump to 2-character label. So it would be DW. Oops, I messed it up. So D. Wait, is it not D? Oh, it's okay. Uh, okay, I activated it. You see how now all the first 2 letters of every word have changed? So this is like, if you type these letters, that's where you jump. So I'm going to type BB and you will see me go here. So in Helix is GW. And then you do, for example, I'm going to do AT. It puts me there. I don't know. I don't think that Flow has it. Just pointing this out as a thing that exists. So were we doing something wrong in here? Yes, because this is like this, and that's fine. Why are we saying that there's a duplicate value? Because that is totally not true. So there's something wrong in this branch here. Um, Wait, no, this is the addition branch, so that's fine. It's in here that we're doing it wrong. So we're looking at before. We first check if they are the same. If they are the same, we continue. Oh, you know what? We missed this. If they are not the same, we continue. When I deleted that line and remade it, I flipped the condition by mistake. So now we do this. Okay, now it complains wrongly, but at least we got a better error. So this is saying this guy is not in your invite list. Well, that is not really true, is it? We are missing an explicit breakdown here. There we go. And now it was deleted. I'm going to try to remove it again. It will complain. Show it again. I'm going to set it to the correct value. This is going to delete it. Let's do show. Now it's empty. I'm going to try to delete this. It doesn't exist. Okay. Add it back. Add it back again. Already present. A, B, C, D. Wrong value. Invalid NID argument. Perfect. Z6MX. Invalid value. Perfect. Show me the list. Yeah, there's values A, P, and then A through D. Let's do delete of B. Perfect. Delete of C. Perfect. Delete of P. Delete of D. Whoops, D. There we go. Okay, so this seems fine as an improvement. Next. So with this, we have implemented, I think, we made good improvements to follow and delete. So git status, GA, everything, GC, add validation checks to follow. We now validates that in that input that NID argument is valid. Validates that invite list has valid non-duplicate values. Okay. Then there we go. Then the next thing that we want to do is oh, no, quit, not here. I guess we're gonna start working on sync. Oh, this is gonna be pain. Oh, you know what? Also, this initial rad sync is a problem because we need to. Damn, we need to. I guess we can add a flag for it. No sync. This double negative really sucks. Okay, let's do it this way. Let's do it sync. We default to true. What is happening? What have I done? No, this is correct. No, this. Okay. So we have sync, and then here we do cmd.sync. There we go. I guess we passed no sync. We should probably pass no sync here as well. Should we respect it here? No. And you know what? I don't think we want to. In the help menu, it's fine. Okay, so Zig build. So that means that if I do it now, it's gonna instant complain, and then if we do no sync, it will not complain. Perfect. Okay, sync. Yeah, something like this. Okay, so now we need to implement this. This is going to be another bloodbath. And also, this is going to force us to reorganize some of the code because we did things that we essentially like tailored things to the other command, um, um, but now having to create a second command will show us what it is that we need to share, and it's going to be a good like extra constraint for evolving the design. So I'm perfectly fine with that. Um, yeah, let's start killing these things because we're gonna start using all of them right away. So first thing that we're gonna do is this. Kind of makes you think that you want to get these from main at this point. So let's go do that because we are gonna need them every single freaking time, except when it comes to help. Like you should be able to do help without this. Yeah, this kind of sucks because you want to handle help and version before you fetch these things. Mm, Okay, you know what? Never mind. Copy paste this for now. I think we're gonna do this same stuff here. Or at least most of it. Okay, let's see. First, we need to parse the command, which is fair. Although right now sync literally does not have any arguments, so there's no need to do that. So for now, no command. Or we could do it anyway, even if we don't. We're gonna add commands. So I mean, that's a you're not gonna need it, but it's a very safe bet. Command equals struct. I'm doing this mainly as a to leave this for to make it easier for the contributors to conform to what the code base is doing. Oh, you know what? No, I'm actually wrong. We do need this because we need this for the help menu at the very least. Um, we need this for the help menu at the very least. So I'm gonna copy this from follow. Oh, this thinks it's a positional argument. Okay. Okay. Again, for now, there's nothing much there, but it's fine. So we grab our command. Want to make a program. So we grab rat. We need built-in. We need allocator. Oh, it's just unused. It's fine. So we ran this. Oh, this is about sync. Oh well, shit. It makes no sense for this to not do sync. The problem is that if you cannot do sync, uh, this is gonna be bad. How are we gonna test this? I guess we'll have to test this on a public repo. There's nothing I can do. So, yeah. So grab our own info because it's gonna be useful. Probably we'll see. Git remote URL. I don't think we're gonna need this. Really. Yeah, I don't think we're gonna need this. So, okay, what's our plan once we are here? Okay, our plan is gonna be look, find delegates, grab their lists. Grabbing their lists means that each one of them needs to be in a stack of things that need to be expanded. And then they also, as we expand them, they also need to be added to a set of things that have already been expanded so that they should not be expanded again, ever again. And every time we expand them, we add what we expand from them back into the thing. And also, it would be nice if, here's the last key piece here. We should not be, so first of all, we need to know when synchronization is necessary because we need to pull a new list that we don't have and when it's not. But even when a synchronization is due, uh, we need to batch them. So we need to make sure that we don't call sync until we have emptied the list of things that we have in our. We need to empty our stack and then remember things that we could not fully resolve yet because they were not in our follow list because we needed to fetch them. And then we need to issue one sync for all of them as a batch, and then we process them again. So batching is fundamental because otherwise this thing is going to have like turbo shit performance. Okay, so yeah, find delegates. How do you find delegates? We can do rad. There's rad inspect -- delegates. That's nice. I wish there was a like porcelain flag or some other flag that removed this. Although you know what, this might be useful information for visualization purposes, maybe something like this. I don't know. Um, okay, so find delegates is easy. Okay, let's create these sets. Sounds like a queue. Why a queue? I think they should be just an array list. An array list of strings. Yeah. And then map. Now, what do we put in the hash map? I think we should put the 32-bit value because we need to validate these keys anyway. So, void. Maybe we could put some information in here in case that it becomes necessary, like useful to provide diagnostics in case something goes wrong. But for now, this seems like a reasonable starting point. Is this unmanaged? It is not unmanaged. So, start from delegates. So here we're doing an alloc print in the arena. I think we should have a dedicated buffer for producing this thing. Now, how long can can this thing be? I don't know. I will guess there's like some max URL length somewhere in our standard library that we can trust. That's gonna be good enough for us. Oh, you are right. Does it have some kind of constant for length? Component? No. What about std.h ttp dot um I don't know, header dot, there's nothing in there. Wait a second. Is there really no URL? My client protocol? No. Wait a second. Do we really not have any like URL related constant? That surprises me. Hmm. 2083 characters for most browsers, which is not something that really matters to us. 2000 characters. I don't know. 2048. And this should be essentially catch unreachable. Plus 33 plus 48. Mm, but these are not always the same length. Are you sure that they can be trusted to be at maximum this length? Yeah, you're probably right that there is something like this going on. But I've seen RIDs of different length. Like they tend to be the same length. And I did 6 at 48. Okay. But here you can see an RID that is slightly shorter. I'll take your word for it though. That well, this should explain what's going on in here. You know what? This is so clear that I'm gonna rename this to just buff. Also, you know what? Here's also another thing that I'm realizing. The prefix is always the same. We don't even need to rewrite it. I'm too lazy to like. I don't feel like doing the extra machinery to not override this. but we could do that, frankly. Anyway, so remote URL is this. Then we need to git show their stuff. Sorry, which is fetch, followed by this, followed by show. And I also think that some of this needs to go into a reusable function. I would say necessarily. Anyway, ref data, blah, 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 tokenize scalar, missing already from git fetch output. Then git show, that gives us the list. And then we kind of need to validate the list. Although I think at this point we don't. Okay, so here's the difference. For we don't want to abort the process because one list has a invalid value. This is a situation where you're running this command, you're pulling it random people's invite list. If one dude somewhere has fucked up their invite list, that cannot be your problem right now. So it should be shown as a warning at worst. There might be even an argument that it's not even worth pointing stuff out unless it's your own list. Maybe you know what? You could argue that this should be a hard error, like inconsistency should be a hard error if it's your own list. If it's not your own list, then you don't care. Maybe you could make an argument for people that are your direct follows, but for sure, people that are not direct follows, that's not your problem right now. I guess RID is 29 characters without the RID column prefix. Yeah, let's see. Base 58 parts and one variable, but maximum 28 characters for a 25 git hash. Okay, thank you. So, so we run this. And then we put we put everything on the stack, or do we try to short circuit? No, we try already to short circuit. 29, 29. I'll take your word for it. Well, the good news is that if we mess this up, this is gonna panic. So we'll find out very quickly, I think. So although wait, this is not catch. This is catch unreachable. I forgot to fix this. Also, we are forgetting stuff because we haven't run the command to grab delegates. Yeah, this is okay. You know what? I think this should all go into a function. We need a function for this function. Process list, something like this. Okay, so we'll go back to this in a moment. First, we need to fetch the delegates. So this is going to be const list equals rad.run, and then we run inspect dash dash delegates. And then we need to parse this. And we're not gonna need to parse these other places, at least for now. So we can just put it here. That's fine. Also, buff can go down here because we're gonna use it down here. So here we have the list of delegates. And so we split it by line. Well, we tokenize it by line. I have no idea if there's going to be carriage return in there, so I'm going to deal with that in case. Then there's going to be the deed key prefix. Then we're going to need to split on space. Or we split on space first. Maybe we split on space first. So while, let's call it line IT. Maybe there's, we can use also index of scalar, I guess. We'll see. This is a line. Then think it's going to be like this. DID equals SD mem dot, it's going to be line 0 dot dot SD mem dot index of scalar U8 slice is going to be line, value is going to be space, or else it's funny that we can put this all in here. Fatal message unexpected output from Brad inspect delegates. Let's do single quotes instead of backticks. So this is the DID. Then if not SED mem dot starts with U8 DID key colon same thing, const need stir is line slash sorry, it's DID slash DID colon key colon dot land dot dot. Then key equals sorry, NID equals, oh, we have key, perfect. So key dot parse need stir catch. Still unexpected output because this thing should not be giving us stuff that doesn't look like a valid NID. So we have the NID value, we have the NID string. What is your problem here? Oh, local constant covers something else. Oh shit, this is your DID. Let's call it self DID. Okay. Then that gets us the NID, and that means that we need to now process process list for, and then we pass stack, scene, and ID. I don't know. Maybe we need to pass something else. Oh, probably we should pass rad and git. See you later, Quint. Okay, so okay, let's think. We do it in this function, the checking for duplicates, adding stuff to scene. I think so. We're missing the NID str. The fact that we are accepting an NID kind of implies. Yeah, you know what? This is weird because essentially what we're looking at is that the delegate's ID is a list, but it's a weird list. Um, it's definitely a weird list. Hmm. Okay, let me think for a second. Yeah, I think that's fair. Essentially, what we are going to do later on is that we will call process list for of a specific ID. We're going to do that in a loop with our stack. Essentially, while our stack is not empty, we keep calling this function. And as we do that, we pop from the stack, we validate. Maybe we don't even push to the stack if something is invalid. We'll have to make a decision there when to do that. Yeah, actually, wait, to be fair, we don't even need to do this here. Wait. Maybe we're going to do this later on. But here, all we need to do once we have an NID is append it to our stack. The problem is we have parsed it, and here we are doing strings. Huh. I would argue that we want to do strings because, yeah, because why? We could copy format. Do we reformat? Hmm. I would say we add each NID to the scene set. No, we can't. Maybe, you know what? This might be a case where we do the validation, but then we don't use this value here. No, we kind of want to postpone the validation. The problem is that if we postpone the validation, this is kind of a special case where, okay, I think this is a case where it makes sense to duplicate the validation so that we can error out early, but then we throw away that value. And so we do, uh, we do stack dot ensure unused capacity. Oh, do we use a GPA? I think for this it makes sense to use a GPA. Additional count is going to be, oh, we don't even know. Holy shit. Guess we can do it here. Mm, and then down here we do, I guess this is an underscore. And here we do stack dot append assume capacity of NAD string. And that's how we get our delegates. And then the rest is just a simple loop. Why did this give me that? What the heck? Okay, so here we parse, we try to parse, and on catch, we don't want to fatal. Maybe we want to std log.warning found invalid NID value. Oh, but we don't know where this is coming from. So maybe what we could change is that we could change. Oh, this is good actually. We could change it so that the stack doesn't contain just the NID, but it also contains the origin of a NID. So you know in whose list it is, because I think that is kind of necessary. So, um, hello, free flow creative. So we could do this, and then we do origin. That makes sense to me. And then here when we append, that means that we don't need to do this. All we need to do is append assume capacity of and then origin. Delegate list. Although maybe we should, you know what? No, I think the hard error is still desirable in this case. And technically, we should never look at this origin. So I'm tempted to put undefined. We'll see what happens. So this is a warning, and then we continue. Because if we find something invalid, that should not cause us to completely give up. So we pop one, we add it to scene. You know what? It might even be that in the end, we don't need a separate function for this. So we get our put using GPA, which, by the way, that tells me that here we want to do the first stack dot the init GPA, the first scene dot the init GPA. At the end of the function, we want to do a clean exit. And we were saying in here, get or put GPA. The value is going to be the NID. Well, the key is going to be NID. And then we do if gop found existing. We continue. This is a node that we already expanded. And then otherwise, we process their list, which doesn't have to be a function. We could actually inline it here. But you know what? Maybe it's not the end of the world. Though you know what? You know what is better than a function? No function is better than a function. That's what's better than a function. No function at all. So you know what? We'll make this function if we ever really need to have more than one call site. So what does this mean? This means that, yeah, so here's the buffer. Fetch the list. Blah, 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 blah. We get to the list itself. Also, wait, some of these things should not be hard errors. Let's double check. Whenever we see somebody, I think we need to ask the question of whether we already follow these people or not. If we already follow them, we will assume that we have locally checked out their namespace. To keep typos to a minimum. Yeah, that's fair. Um, Okay, before we fetch the list, we see somebody. I think the first question is, are we already following this person? So maybe we should collect the follow list before we do this. Yeah, I think we need to collect the initial follow list and then we need to update it as we issue our own git follow commands. Okay. Give me a second. I'll take a very quick bathroom break and then we continue with this. Be right back. Okay, I'm back. Okay, so what we were saying is, um, uh, Jesus, I don't remember anything. We need to check if we should expect to have this data already or not. If the right, the idea is if the NID is in our follow list, we should have the data. Or maybe this is more like the opposite. I think here we should say if the NID is not in our follow list, then we don't expect to have the data. Which means that what we should do um, is put this NID entry into a separate stack. Stack deferred. They have the same payload. We should make a type for this. And um, yeah, actually, this is going to be duplicated if we do it this way. Um, I don't know. I think for now it's fine. So that means that we need a follow list, which we are missing, which is part of the initial setup. So we run sync. We get information about the repository ID. We know who we are, but now we need our invite list, our follow list. So run follow. Yeah. Well, this sucks because this is look. This table is delightful. Unfortunately, it's very resistant to programmatic parsing. What if we type into a file? Shit. Damn. So the config does not contain our follows rat self. Nope. Hi, will Zig leave Codeberg and start using Radical? We don't know. I'm essentially testing Radical out. So we are interested. I'm interested for my personal projects. I think we are interested for the Zig project, and I think it's also interesting for Zig users as a think of it as like a resilient way of fetching packages. So there might be use of Radical in the Zig ecosystem, even if the Zig project were to not use it. And to be fair, not everything that applies to the Zig project, so like to the development of the Zig compiler itself, should necessarily apply also to users. Um, but yeah, there's interesting possibilities there. How will normal users be able to clone the repo, etc.? So if you want to clone the Zig repo and whatnot, this is possible with Radical. So if you go to radical.network and you click explore, and I think here you can already do Zig, and it will show up. By the way, Zig is already on Radical. Now we're not really, again, this is like just a test. We're not really using it much, but it's just for just to test it out. But if you want to clone it, once you have once you get to the Zig to a copy of the Zig repository via the GUI, here there's the clone button where you can clone via Radical. This is going to be a clone that requires to have the Radical tool installed, and it will allow you to create issues, create patches, interact with the development of Zig. But if you just care about the source code and you don't give a shit about Radical, there's also the git clone option. So essentially, there are multiple hosts that will have Zig in them. Iris radical.garden is index radical.garden is one of those, and it can serve the Zig repository to you if you want. Alternatively, for example, there's rad.alexrp.com. This is Alex, the core team member, AlexRP, and he has in here sorry, I went right because I did this. Let me do this, and then we need to refresh. So Alex also seeds the Zig repository, so you could grab it from him. There's a single source of truth. It depends on how you interpret the terminology. So Radical has a mechanism for you to know what is official and what is not official. Andrew is a delegate, which means that he is has the authority to create official commits, official references, like official tags, for example. So whatever he does with the master branch is the canonical branch. So this is how you know that something is official. And this is also how you know that what you're getting is correct, even though you're getting it from another host. Well, if you use the Radical tool, Radical will do the cryptographic checking out of the box. But in general, this is not like a fork where in a fork people can make arbitrary changes, right? So, or rather, let me put it this way: this can work as a fork. Like Alex's server can hold. For example, we have changes from this guy Homer. I don't know who that is, but this person has their own master branch, which is either modified or behind, but the commit is different, right? So this can host other people's changes, which, and by the way, making a branch is how you can initiate a patch, right? So it's not like people make changes because they're malicious. People can have legitimate reasons for wanting to make changes. But in any case, the official stuff is the one marked canonical, and this is all validated cryptographically. So it's not just some random dude's opinion. Yeah. So Turbofish, if you are interested in Radical in general as a topic in the context of Zig, I wrote a blog post that maybe you might find interesting if you haven't seen it yet. I also sent it on YouTube. Also, sorry, YouTube people. As usual, YouTube chat fucking sucks, but I'm gonna see your messages now. I've already read it. I just didn't know if it was only personal or for Zig as well. Well, we are interested. We are not ready yet to make a decision either way. So part of what I'm doing right now, implementing an invite tree, is also a prerequisite to keep looking into it because we want to have an invite tree. So the question is, can you implement an invite tree using Radical? If you can, awesome. If you can't, that might be a problem. And now, between me and being able to implement this, there's a goddamn table. God damn it. What is an invite tree? An invite tree is essentially a mechanism where before you are able to create an issue or open a patch, or a patch is what Radical calls, what GitHub calls PRs. So a GitHub pull request is a Radical patch. So before you are able to open a patch or an issue, or more precisely, you can open those regardless of who you are, but with an invite tree in place, they will only be visible to people in the core team if you have been invited by somebody in the invite tree. So it's essentially a list of lists where it starts with, let's say, for simplicity, it starts with Andrew. Andrew invites people in the core team by having a file that lists the Radical IDs, these things, the DIDs of me, Amlag, other people in the core team. And then we will have our own lists. And so we in turn will invite other people. And that way essentially is a way of soft gating access to collaboration in the Zig repository. This is because right now there's an overwhelming amount of issues and PRs that need to be triaged, and there's a also non-trivial amount of low quality contributions, like stuff that has been hallucinated by people overusing LLMs. And this is a mechanism to essentially distribute a little bit the load of filtering these things. That's an invite tree. Yeah, kind of like lobsters, pretty much. Very few will participate. Well, it depends. I think that the bar for being invited in lobster is probably higher than being able to be invited in contributing to the Zig repository. The idea is that the moment that you show somebody that you have like created an issue that isn't insane, or a PR that patch, sorry, that also isn't like pure slop, that is enough essentially to be invited. So, I mean, not that lobster has a extremely high bar either, but I think in general you can decide how you want your invite tree, how exclusive you want your invite tree to be, and I don't think that the Zig one is meant to be super exclusive. At the same time, let me tell you another reason why an invite tree is desirable. In Radical being a peer-to-peer thing, there's also a bit of spam. Or rather, sorry, let me take a step back. On the internet, there is spam. We have been hit by spamways on GitHub. We have been hit by spamways on Codeberg. And in those cases, the people running those services have been managing the response to spam. On Radical, spam exists, and it being a peer-to-peer network, roughly speaking, you have to put more effort into fighting spam because there is no centralized authority that can make a decision with regards to spam that automatically propagates to everybody else. What I mean by this is that if somebody creates a spam issue where, it's like quite literally spam, I can ban them, but then you will see that spam issue until you ban them from your own node. And so the same spam removal activity has to happen the same decision making has to happen multiple times for all participants. That's annoying. That's also kind of by design because by being the virtue of being a peer-to-peer network is that there is no centralized authority over anything. So the invite tree is also a way of coordinating around this decision making. How has been the experience of moving to the new Git host? Is it more stable, faster than before? You were talking about Codeberg. Codeberg is better than GitHub, generally speaking, but it is not perfect either. It has downtime. It has occasionally missing features. It has also features that are absolutely on par with GitHub, but that maybe should have been different all along. So, for example, I think I just pushed a patch to Super HTML on Radical. Let's see. What am I doing? Super HTML, rad sync, rad inbox. Yep, I see it. So as I was saying, Codeberg is not perfect either. So first of all, we've seen spamways also on Codeberg. Occasionally, Codeberg falls apart because we're not a giant project, but we're big enough to stress their systems. It got kind of bad because as of late, people have been unable to fork the Zig repository because there's one thing that GitLab does, which is questionable, which is that whenever you make a fork of a repository on Codeberg or Forjo, so the software that you could also self-host. So it's a problem with Forjo, not Codeberg specifically, but Forjo, whenever you make a fork, you will create server side a new separate clone of the original repository. So that means that if there are 10 people that forked Zig, it means that there are 10 copies of the Zig repository on the Codeberg hard drives. They start with hard links to the same files, to the same Git pack files. So it doesn't immediately bump up the hard drive usage. But the moment things go out of sync on either side, like the moment that either side makes a commit, these files go immediately out of sync and they materialize as duplicate files. Well, not entirely duplicate, but mostly duplicate files. How does Radical do this? Radical is not the only one that does this, but essentially in Radical, all forks, the fork terminology doesn't really exist in Radical. They're called seeds because they are both essentially a fork in the sense that you can modify them, but they also act as a mirror of the original project, so you can trust them in a way that you can't trust forks. But setting that nuance aside, in Radical, all seeds are one repository that uses Git namespaces. So whenever you make your own branch exists under a namespace and under a specific Git namespace that allows you to create your own branches that could collide by name with other branches, but they are kept separate between you and other users. And so any form of duplication, like because this is a single repository, there is no duplicated data. I think GitHub does the same, and I think also other like Git forges do the same. So it's something that Radical does, but it's not unique to them. In a sense, it's kind of the opposite. It's Forjo that is somewhat unique in the choice of not doing this, and that eats memory a lot because again, somebody just creates an account, presses the fork button, boom. These are now 300 megabytes that have been burned. Because I think 300 megabytes is, roughly speaking, how big the Zig repository is. There's two of them. I'm not sure why. You mean these two entries? Because one is a notification about you updating a branch, your own branch, well, your own main branch, and this is you creating a patch. So I agree that it's debatable whether this should be an entry in here, but that's like a design choice of what you decide to put in inbox. By the way, I did inbox, which is notifications. I could do rad patch, and that just shows me patches, and it shows only one of them. Could you have been better off self-hosting GitLab? No. GitLab is, well, first of all, GitLab is Ruby. You know what? This is not a choice entirely up to me. So I'll speak my mind. Other people in the core team could have different opinions, and I do not mean to speak for them. But God damn it, I never ever in my life want again ever to run Ruby software. I don't care. I don't want to run Ruby software. I don't want to run Python software. These things are just way too fucking janky, and I don't care. Forjo has going for it that it's written in Go, so it's more solid in practice when running it. Although, you know, there has been some drama recently about their coding practices. I don't know if people remember the thing where there was somebody who found a bunch of vulnerabilities allegedly in Forjo, and they made like a post. According to them, there were way too many, and they didn't trust the Forjo people to actually really care about them. Like, to them, there was like a methodological problem, like a philosophical problem with their approach to security. And so they made a blog post essentially calling them out. Now, I don't know who's right there or who's wrong. There's obviously, as usual, discording opinions. I don't know. But the point is, I guess Forjo is probably better than running Ruby software, which I believe GitLab is. And while I have not run GitLab itself, so I cannot speak with from first-hand experience, and I might be wrong, but I have run Ruby software. I've run Forem, the CMS that made by the dev.to people, and holy shit, that thing was a nightmare. And also past experience that I've had running Ruby projects, I don't like it. Also, it's insane when you have this project and there's like a type mismatch. I can't. I just can't anymore. So, long story short, should have we self-hosted GitLab? I don't love it from this perspective. Also, GitLab is not... it's still another startup. They're going to shitify. If I haven't shitified yet, they will shitify. That's guaranteed. So, you know what? Maybe it would have been a good solution. I don't know for sure. It could have been. We didn't try it. Right now, Radical seems strictly more interesting than all these other options. So let's see what happens with Radical, and then we go from there. So sorry, Chris. Thank you for the patch. I'll take a look at some point. Right now, I really want to focus this so that we can move forward with, like, this pertains the core team, not just me. So I need to give it priority. What are you coding? A invite tree for Radical. If you go to radical.dev, you can learn more about Radical. It's a decentralized Git forge. Well, so how do we grab the follow list? Man, verbose really does not help at all. Jesus Christ. I don't think there's a rat command for us. I think we're toast in this sense. Or rather, I'll need to try and survive the. I guess I could temporarily try to survive the table and essentially then turn this into a request for the radical people to give us a porcelain flag for these commands or something like that. Look at the socket protocol. You know way more than me. What would you suggest in like more concrete terms? You could load the follow list directly from radicalnodepolicies.db SQLite. Oh Jesus, no. Dependency on SQLite. I think that so obviously the right solution would be that the RAD tool has a proper CLI interface for it, right? As a temporary workaround, I think I would prefer battling the table rather than depend on SQLite as well. Is it a Git clone? No, it's a Git forge. So it depends on Git. It uses Git. There's control.sock. I see. Yeah, you know what? Let's find the goddamn table. I guess it's fine. We split lines, and instead of searching for a did key prefix, we search for a Unicode symbol space did key start, and that's gonna be good for now. So let's grab the list. Let's grab the friend list. Follow list. So what do we do with follows? I think that since we're making this another hash map, I think this one should also be decoded IDs. So const list equals rad dot run follow. The verbose flag does nothing. You know what? Alternatively, the verbose flag should do something about this. Also, passing it, not passing it, doesn't seem to change anything. Which also seems kind of like a thing that was like left. Like it almost feels like the flag has not been wired in. But you know what? Let's do it without the flag for now, so that if they ever change it, we don't break for no reason. JSON. No, that would be nice, but no. So we run rad follow. So we split lines and we filter lines and start with the special DID key mambo jumbo. So var it equals cd mem tokenize u8 list, and then we do new lines, also carriage returns. I don't know why I care about carriage returns in this context, but whatever. Yeah, in this context it's not that important, but it's fine. um so here we do while it.next if line dot std mem dot start with um holy shit. Well, that's what you gotta do. If it doesn't, we continue. If it does, we strip it. um Hello, Matt. There we go. um so with this we have the follow list. And so with this, now we can go, I don't remember where. We can go right in stack pop and say, okay, if the NID is not in our follow list, then we don't expect to have the data. So that means they want to take this value and append it to the third stack. And at the same time, we do we issue rad follow. We update our local follow view, and but we do rad follow. We do rad follow. Oh shit! This does not. This does not accept no sync. So hopefully this does not try to sync stuff. You know what? We can mess with this. I think rad follow, and then I'm gonna make a fake one. Okay, so that works. Rad unfollow removed. Perfect. Okay, so that works, and that doesn't trigger a network activity, so that's good. So we do rad run follow. What if we run follow of somebody that we already have? Still not a problem. And unfollowing somebody that we don't have, still not a problem. Okay. Follow and then NID stir. Oh, there's not pen assume capacity. There's only put assume capacity. Oh well. Put GPA NID void catch error fatal dot boom, and then we do stack the third dot append GPA NID. Actually, no, it's the entry. Catch error fatal dot boom error. And then we continue. Okay, Zig have exceptions? No. We have try and catch, but they are not tied to expressions. They are ways of wrapping and unwrapping. Well, they are ways of unwrapping error unions. So if we don't have them in our follow list, we update follow, we update this. Oh shit. Here's the problem though. Could we find duplicates as we do this? I think yes. And if we find a duplicate and we have added them already as a follow, then we'll think that we do have the data. So we can't do this. So that means that we will do this and this as duplicates, which is actually fine, but we cannot do this. Okay, so we keep doing this. Then we need to think about the case where we actually do have the data. But you know what? I'll skip that for now. So what happens um, when we are done with the stack? Essentially, we need another while loop, which I think is going to be while stack.items.len is greater than 0, or stack deferred items len is greater than 0. We'll want to go through this whole routine multiple times. Where does it come from? Fatal.zig made by me. This is this is maybe controversial, so adopt at your own risk. But here's what I do. So this is just convenience, right? This just prints out of memory. It accepts a argument that is required to be a error out of memory, or rather, it accepts an argument that is an error, and the error can only be part of a error set that only contains error out of memory. I'm doing this as a form of protection so that I don't, by mistake, map errors to So this is essentially protection against programming errors, nothing else. While MSG is essentially, think of this as std process.fatal, except that this in the bug builds sends abort instead of exiting. I like it because when I run it in the debugger, the signal will cause the debugger to hit a breakpoint instead of it will cause the debugger to pause execution, and instead of having the executable exit. MATLAB was pointing out that I could just set a breakpoint on any call to std process.exit, which is fair. I don't know. I think I still like the convenience. Also, let me see, std process.fatal. Also, I'm not sure that I like using the log interface. So I would say this is more opinionated. This is better. Maybe this is less opinionated. This is, I think, more generally a good idea. So essentially, if you want to be less opinionated, you could do this. That would also work. Obviously, though, the question is dying on the right choice for your program? Because it might not be. This is a CLI tool, and essentially, if we it's probably a good idea to just give up. But for another program, you might want to have more nuanced out of memory management. So don't forget about that. Okay, so let's say that we have popped all entries in our stack. So what do we do? Done popping from the main stack, sync and move the first stack we want to sync and swap stacks. Oh, this is gonna be funny. So essentially, we have the main stack is empty, and there might be entries in our deferred stack. And our deferred stack is our deferred stack will be essentially materialized by running rad sync. Then every entry in there becomes again an entry in the main stack to use, which we could, pop and push, but there's no point in doing that. It's easier to just swap stacks around. So what we do is, I guess let's do an if stack defer.len is greater than 0 dot items. When items.len is greater than 0, then temp equals stack. Stack equals stack deferred. Stack deferred equals temp. Swapped. Yeah, const. Okay. And then we loop again. So swap the stacks, go back here. Now keep doing this. Okay, now we need to implement what happens when we find them. Okay, so uh oh, wait though. We need to put these people in our local follow list. Because we've issued the outer follow, but we need to issue the inner follow. That requires a for loop. So we need to have a for loop regardless. What if catch also push error? It can't. When you are inside a catch, sorry, no. What am I saying? I'm dumb. No, in catch you can return an error. Yeah, you can. Um, it's just normal control flow. Think of catch as the equivalent of goes if different than nil. If different than nil, you can still return an error if you want. So it's the same idea. It's just that it's less verbose in Zig and less error prone. Oh, you know what? We need to do this before we swap them around. So I'm gonna use stack deferred, but then I'm gonna move this above. Okay, so this should be right. So we go up again, and if we have anything still, this should be. Oh, you know what? We need an assert. We should assert that stack is empty now. You know what? I'm gonna put it up here. Okay. This all seems great. We now need to actually do this. Fetch the list. So ref data, blah blah blah. Follow. That works. The problem is that this might fail. This might not be there. So I think we're missing a key component, which is running a command that on failure doesn't error out. So essentially, we want to do this. Yeah, we want to be able to run this and expect it to fail if a given remote does not have the ref. So we're missing a tiny piece of infrastructure. Mm, something like so we could make this return an optional, so that would allow us to do or else continue. So run fallible. Yeah. Let's see if we can implement run fallible. I mean, one way or another, I'm sure we're going to be able to. It's just that it may be annoying. So right now we have run std in that is the core of it. Um, but we essentially want to split this in two, I guess. Or we just want to run std infallible. Although we're never gonna need this to be like this. We only need run to be fallible. Oh. Oh, it's okay. Run std infallible. Oh damn. We don't have full args. But that is fine because this can be. And then we pass before it. Let's do it up here. We pass program dot path. So this also, we just do it manually essentially. That's fine. Okay. And so now we can do run fallible. So if result dot term is, we need to switch. Technically, um, I think what we should do is we expect the program to exit with a non-zero exit code, because if the program crashes with like a signal or something, that's that is not something that we should silently do. So returns null if the program exits with a non-zero exit code. So let's do it like this, maybe. And then we copy this. So we still want to crash if there's like a signal or other weird stuff going on. So, or else continue. If we have this, then we expect it to make sense. So yeah, it's an error if this does not make sense. Then we do show, and show should give us a list. Now, what if show fails? I think that this needs to be around fallible. And in or else, we should do log the warn. Found invalid get object ID in ref invites invite follow for user for NID. Do we need the quotes? I don't think we need the quotes. But I think I quoted it up until now, so I'll keep them. And the NID is NID stir or something. Do we have that? Do we have that around? We do. Okay. So we have the list now, and now we're processing the list. Okay, so we are now finally, for the first time, processing an actual list. Do we make a function for this? Again, we don't have other call sites, so let's not make a function if we don't have other call sites. So var it equals std mem tokenize u8 list this. Then I'm actually realizing that there's no point in tokenizing also in the carriage return. All we care about is no, never mind. It is a good idea to do that. So while it.next line const NID stir equals trim line trim white space key parse stir catch log in invite list of NID. Okay. And if we do this, we continue also. Okay. And essentially, if it's correct, all we do is push it on the stack. And you know what? We can also do this. Ooh. Do we put a limit on how big somebody's list is? I think we should put a warning if somebody's list is too big. We should surface that information. It's not much about inviting the whole world rather than figuring out more easily if something goes wrong, like if somebody is doing something sus. So there's a problem because we could count the lines, but actually also the size in bytes is too much. Could be too much. So maybe we should try to put a limit on that, except that putting a limit on that actually should happen in the fetch phase. Like as we fetch, we should say, well, we shouldn't fetch something that is way too big. Although at the same time, that fetch is already too late because the question was, we already have the data in our local computer when we did rad sync. So there should be a policy in rad sync to not pull in ginormous stuff. You know what? Let's print a warning if it's just very long. So um, I would say that if you have more than 1,000 people, it might make sense to print a warning. For example, maybe 1,000 is too low. Or it could be a piece of debug information. Oh, here we're parsing this right. Okay, so here we are facing the problem where I don't know yet where is the best place to put this, because here we're doing it as we are parsing the list. But before we were doing it as we were popping from the stack. So I think we should have the assumption that what we put on the stack should be trusted. So that means that we don't need a check when we pop. We should assert. Yeah, look at this. Huh. Yeah. So this is fine. And up here, we need to do catch unreachable, validated on append. Is this true? Yes. And yes. So this can actually be an underscore because we don't need it. Or no, actually. What's in an entry? Only the string, okay. Um, nope. Okay, there we go. This part was weird. This is neat, sir. Oh shit, this might be wrong also. Oh damn. Zig has less than 2,000 contributors, so 1,000 invites should be a nice limit. Okay, I think we need to make sure that we're not accusing the wrong people of doing things. So when we pop an entry, this was a line found in somebody's file. For these entries that are um, in the stack from the what's it called? From the delegates lists. I mean, frankly, you know what? We actually have a value to put in here. It's not like we don't. It's from delegates that we do this. No, these are the delegates themselves, right? We could put this. Hmm. Anyway, let's see. Cut scalar. No, that's not what's happening in there. That's slightly different. Yeah, delegate list. I think that should be the right name. Then, okay, let me see. We pop from it and we say invalid NID value invite list of origin. Yeah, but then when we put it, is this the invite list of origin? This is not the invite list of origin. This is the invite list of this guy. Oh shit. Oh damn, we're also messing up. So it's not self NID STR, that's for sure. It is need STR. Yeah. I'm starting to think that origin was never needed. I think that origin was all along a red herring. Yeah, it was all along a red herring. Infernauta, thank you for the prime sub. Thank you very much, good sir. Much appreciated. So let's get rid of origin. Let's collapse stacks back to being just NIDs. We don't need this. Absolute red herring. We don't care about this for now. Okay. We don't care about this. That's fine. That's good. Um, okay. I don't want to alarm anybody, but this might be it. The problem is to really test this, we need a public repository and we need to do stuff to it. So here's what I'm thinking. It's getting already a little bit late, and I have a meeting in a couple hours, so I need to figure out dinner in the meantime. And I think this is good. This could be a good checkpoint. It's unfortunate that I haven't had. You know what? We can make sure that it builds. But then after that, I don't have time to test this out, and that will have to be something that I do on my own later today or tomorrow. But this is good. This actually shows that the implementation can be pretty elegant in the end, and the fact that we have to iteratively fetch from a remote host, which is a performance killer, the fact that we can batch those, it actually gives me a lot of confidence, because it means that we essentially have to run it once. If you think about it, the worst case is that we run the iteration once per level. So if we have a tree with 10 levels of depth, worst case, we run sync 10 times. And it's big O of 3 height or depth. That's fine. That is manageable, I think. That is, I think, definitely manageable. So that's good. And actually, there are even tricks that you can employ to um, constrain the tree's height. Oh my god, this is like really manageable. Holy shit. Okay, let's get it building and then we'll see. So parse has the wrong signature. Fair. Next problem. Auto array hash map file struct. Oh, there's no auto array hash map. Right, it's because it's auto array hash map unmanaged. Source file struct mem does not have tokenize. Oh yeah. Oh damn, I'm dumb. This is tokenize any. Follows append assume capacity. Yeah. This is put assume capacity. There's another tokenize. Consuit does not support structure initialization syntax, right? 126. Error union type out of memory. 135. Scene get or put. We could change this into a get or put assume capacity, because here we could do scene dot ensure unused capacity of stack dot items dot len. That actually seems pretty cool. Items, items, okay. Extracted U32 found U size. Really? Hintcast. No member named NID source in const U8. Yeah. Put us in capacity. What do you not like about it? Oh. Oh, damn. Right. Clean egg. Oh, clean exit once IO, I guess. There's no the init. Really? Where's my the ninit? Accepted a constraint found run result. Expected constraint found God knows what. Wow. Oh. Oh. Okay, we built. Yeah, as I said, I don't have now time to really test this, but at least we got it building. So I think we can make a commit and then just point out in the commit. Okay. So uh, this is not bad as a start. Maybe I prefer this like this dot and then yeah. Okay. You know what? Oxford commas. Let's go. Okay, I like this. You know what? Status git add dot is gc amend and git push force, which we can do. That works. Okay. So as I said, thank you all for hanging out. Man, this was a good chunk of work that we did today. I did not expect this to go this smoothly, although we haven't tried it yet. So uh, I'm sure there's a lot of nasty surprises that we haven't gone through yet. But so far so good. I'm happy that the overall structure is um, really simple and and manageable and not too inefficient in a variety of ways. So yeah, really happy with the result. Thank you all for hanging out, and tomorrow maybe we'll go forward with this again. So thank you, and see you next time. I think I'm gonna be lazy. I don't think I'm gonna do a raid. So there's Lucas Developers doing Zig. There's T2SDE. You know what? As I said, I'm gonna be lazy.